as we look at the different information, area of a rectangle, you've already had to calculate that on the previous lesson. It is length times width, base times height. Area of a triangle, you know as base times height divided by 2. Sometimes people say 1/2 the base times the height, which is perfectly okay if you say that. You can take half of the base and multiply that by the height. You can take half the height, multiply it by the base, or you can multiply the two together and divide by 2. Not a problem with that. Cylinders and prisms. What's the difference between cylinders and prisms? What's that? They're all straight lines. They're all straight lines, which means polygons. And what about a cylinder then? Cylinders have straight lines. Yep, you're going to have a curved segment. Usually when we think of cylinders, a lot of people want to say that a cylinder is a tube. A cylinder is this. But keep in mind from Algebra 2, we know that a cylinder could have a base that has that semicircle and then a trapezoid attached to it. If this were a three-dimensional figure that came out to the wall, out of the wall, not to the wall, that came out here, then we would consider that to be a cylinder. What's the difference between, okay, what's the difference between the cylinder and prism versus the pyramid and cone? A cone is like a cylinder, has a curved piece, but it comes to a point. So the thing is how many bases you have. A cylinder has 2 parallel bases where a cone has 1. And the same thing when you talk about a prism versus a pyramid is whether you have 2 parallel bases or whether it comes to a point. Okay, so that's review, right? I know it's review, I just covered it in algebra 2. No, that's review. Just one moment. No, it's just in the beginning. Okay, oh, and I recorded it. Okay. As we look at that, then, so the difference is going to be whether you have 2 bases or whether you have 1 base. Cylinders and prisms, you're going to have 2 parallel bases, and it's whether they are polygon bases or whether it has a curved segment to it, non-polygon bases. The naming of it, do you remember how you name cylinders and prisms? You named the base, what base it is. Okay. And then you, yeah, this is a triangular prism. Yeah. This is a rectangular prism. If you say a square prism, then the base is square, and sometimes you think about the cube, a special cube, you know.
I think the cube has
So, has its own name?
yeah.
It's a special type. Just like a square is a special rectangle, a special type of parallelogram.
What do you call a square prism?
Okay, what about this one?
That's an octagonal.
It's octagon. So this is an octagonal prism. Now we can get more specific. What's the difference between right and oblique? Right means that the altitude or height is going to be perpendicular to the base. Oblique is going to lean. It's going to be offset. The two bases are not directly above each other. They're going to be offset just a little bit. Oblique? Perpendicular? A rhombus? Yeah, a rhombus is oblique. Can be, yep. A square is a special type of rhombus, though. Definition of rhombus is that it has 4 congruent sides. All right, things that you should have on your note card. How do you find the volume of cylinders and prisms?
The base, and then you put the area of the base, the times the height.
Very good. Area of the base times the height. Because when we're talking volume, you're thinking how many cubes can you fit in a given amount of space? 3-dimensional. So the first thing you do is we're going to look at the squares on the floor. How many squares are there? And then you're going to set a box on each one of those. That's area of the base. And then how high, how many layers of those boxes can you put? That's the height. That's fine, whatever you got to put down there, but that's what you're finding. Whatever the shape may be. You find the area of the base, and then how high can you stack that? So volume of a cylinder or a prism is area of the base times the height. Lateral surface area. Lateral surface area means what wraps around it. Do you remember how to find lateral surface area?
And then just the, yeah.
Lateral surface area is what wraps around. So if we talk about, it's like the label of a soup can. So if we talk about what wraps around, but what wraps around this, it's like the soup can. But when you open it up, it's a rectangle, so it's going to be base times height. But what is the base right here the same thing as? In this case, it's going to be the circumference. So what we say, so that it covers any shape, if it's a circular base, it's going to be circumference times the height, 2 pi r times the height. But in any case, we're just going to refer to it as perimeter times the height. Perimeter times the height. Perimeter, just find the distance around your base, the perimeter of the base. I don't know if you want, you could put a little b here so you know it's the perimeter of the base times the height.
So even on a prism, you were just on the side though.
On a prism, there's different things you could do. So like this triangular prism, you see 3 faces that are triangles. So or rectangles, sorry. So you could add each rectangle together, find each one separately and add it together. Or you could take the perimeter of this triangle and take it times the height. Because the height of these 3 are going to be the same. What you're doing is you're multiplying by possibly different lengths here. So it'd be like factoring it out. Yeah, perimeter. Add the sides together, and then take it times the height.
So you would find
In a cylinder, find the circumference because that's the same thing as perimeter. The only difference when you were talking about, if you were, if you talk about that triangular prism, let me just create one. Do you see a triangular prism? Okay, out of this triangular prism, the white, the note card, is your lateral surface area. And out of that lateral surface area, if I were to open it up, you still have a rectangle, right? So what you would do is to find this length right here, what would it be? The sum of the sides. So that's perimeter. So it's perimeter times the height. If you wanted to, by all means, you can find this rectangle, add to it this rectangle, and add to it this rectangle.
that's just lateral.
That's just lateral surface area, not total surface area. If you wanted total surface area, or if they just say surface area, they're referring to total surface area. And to the lateral surface area, you have to add what? 2 bases. So it's going to be twice the area of the base plus lateral surface area, which means it's going to be twice the area of the base plus perimeter of the base times the height. Now keep in mind what your height is. Keep in mind what the height is. Don't do the wrong height. What you think might be the height. The height is going to be the distance between the parallel sides. Especially when you start talking about triangular prisms, because they won't set them like this, they're going to set them like this. So you just got to be careful of that. Okay, so far then? All right, the next thing. So the base of a right cylinder, like I said before, a cylinder is going to have a curved segment to it. Too many times we want to think of this, a circle for a base, but this could be a cylinder as well. So the base of the right cylinder is 10 centimeters. Okay. The base of the right cylinder is shown, and it's 10 centimeters high. Find the surface area of the right cylinder. So if I want to find the surface area, your surface area is going to be twice the area of the base plus lateral surface area. You did these last year. This example. This is for a cylinder or prism. Yeah, it was on the last slide. Did you get this? Total surface area? That's what we're doing here. Yep. Twice the area of the base plus lateral surface area. Okay, so we look at it. We got to find the area of the base, right? So area of the base is going to be equal to area of a rectangle plus half the area of a circle. What's the area of the rectangle? Right there is 30. Length times width. Plus, what's the area of your circle? Well, semicircle. You look at it, and a whole circle would be 9 pi r squared, and I have to divide it by 2. That's the area of one base. So this part right here is 9 pi over 2. So what I have to do is I have to double the area of the base. The area of the base was 30 plus 9 pi over 2. I got to add to it lateral surface area. You will, yeah. Lateral surface area, if I talk about lateral surface area is going to be equal to the perimeter times the height. What's your perimeter? Well, the perimeter is 5 plus 6 plus 5. So 16 plus, and then I have this curved segment right here. So that part's going to be 2 pi r, but I only have half of a circle, so you divide by 2, and you get pi times the radius. So it's going to be 3 pi. And I have to take that times the height. What's the height of your figure? Remember? Because too many times people come here and they get to this and they just go, it's pi r. And then when I ask you to find the circumference of a circle, people say pi r. The area of a whole circle, because it's half of the full circle. And a full circle is 2 pi r. And you want half of it. So that cancels. So therefore it's just pi times the radius. Right, so the height between the two bases is going to be 10. So I'm just going to put that over here. So perimeter of the base times the height. All right. Now to solve, you have to use the distributive property. What's that going to give you in the first part? 60 plus 9 pi. The second part's going to be 160 plus 30 pi. And I can group these two together to give you 220 plus 39 pi. It's surface area, so your units are where? Oh, right there. Got it. I had it typed out instead of abbreviated, so that's what I was looking for. So square centimeters. So there's your area. You have a piece of paper? You need to get that out. And in that figure, you're going to find out that the radius of your large circle is 10. You find out that this is 11. I'm sorry I did not draw it to scale very well because obviously this is not the same as that up there. So there's 5, and they also mark this as 11 for you. What they tell you is that there's 2 parts, but we're only going to work with 1 part. The figure below shows the base of a right cylinder that is 9 centimeters high. It's actually more parts than that. It's a total of 4-part question. Find the volume of the right cylinder in cubic centimeters. Find the surface area of the right cylinder in square centimeters. Actually, it's maybe 3 parts. Right, so what we need to do is find the surface area of the right cylinder. So surface area. We're not going to find the volume yet, just surface area. So it's going to be twice the area of the base plus lateral surface area. Twice the area of the base. The area of the base has 3 parts to it, right? Yeah. The area of the base has 3 parts, which is going to be, once again, half the area of a circle plus the area of a rectangle plus half the area of another circle. If those circles had the same radius, I could put them together and call it one whole circle. They're not. They're 2 separate circles. Lateral surface area is perimeter of the base times the height. So we're breaking it into parts. Break it down to help make these problems less difficult. There could be, but if you don't break it down, then a lot of you sit there and you're like, so we have 2. No, actually, breaking it down, you might skip something, but I think if you just try to do it all mumble jumble like some of you do, you're going to skip something as well. And if you break it down, you're breaking it down into simpler parts, hopefully. Okay, so the area of the first. Let's talk about this half the area of a circle. So I'm going to refer to this circle right here. So if I refer to that circle, it's going to be pi times 10 squared, and we're dividing it by 2. Pi r squared divided by 2. The area of the rectangle, which is this part right here,
110.
so that's going to be, keep in mind this distance right here, I agree, is 10. It's the same as the diameter of that. So it will be 10 times 11, or 110. I'm just going to write it as that for right now. And then we are going to have, in addition to that, this right here, which is pi, the radius, which is 5 squared, divided by 2. And now I'm running out of room, so I gotta do this little thing. Group together. 28. Slide this over here a little bit. Group this together. Questions so far where one of those values comes from? Not yet. Are the colors okay? We can still see. Can you see that all right? Or do we need one light off? We're good? All right. The next thing then, we have to have perimeter of the base. So we're going to add to it. And I just want to do perimeter of the base times the height. So I'll put that in here in just a minute. All right, perimeter of the base. Perimeter of the base, I have 11 plus 11. So we're going to have 22. Oh, let me find another color here. Plus, what's this curved piece going to be? Oh, wait. I'm going to change my 22. And this is a common spot where you mess up. I'll tell you that right now. What did I forget with those straight pieces? That 10 right there. So we have 32. So the straight segments are 32. And then we go back and we're going to find the curved segments. And if I looked at the curved pieces, remember that's 2 pi r, but I only have half of it. So it's the same thing as pi times radius. So this is 10 pi. Would you agree? And how much is this right here? That's going to be 5 pi. And if I group those together, you get 15 pi. So plus 15 pi. And in the book, since I didn't write that down, how high is that cylinder? 9. So I need to take it times 9. I'm going to give you a second to think about that and ask me whatever question you have. Now we're going to calculate. I'm going to do this kind of in 2-step right here. I'm going to take 2 times this fraction. And if I were to take 2 times pi, 10 squared is 100, and divide by 2, those 2's are going to cancel. So this first part is just 100 pi. I have 50 pi here, and I got 50 pi out here because it's a cylinder. It's like a whole circle. The next one. The next part is going to be 10 times 11, which is, no. It's 110. And you take it times 2, which is going to make it 220. Is that okay if we do that kind of all like that? And the next one, what's going to happen with the 2's again? The 2's are going to cancel, and you're going to be left with 25 pi. That's the area of the 2 bases. That's the sum of the 2 bases. The green over here is lateral surface area. And if we calculate that, we got to use the distributive property. 9 times 32, 288, and that looks like 2.88. And then I take 9 times 15 pi, which is what? 9 times 5 is 14. 9 times 5 is 45. 9 and 4 is 13. We agree?
Yeah.
All right, what can we group together? So now the overall answer, we group the pi's together, which is going to be 55. 60 to 60. 260.
Oh, yeah, it'll be 260, yeah, right now.
260 pi, and we're going to group 220 plus 228 to give you 508. Units, we're dealing with surface area, so it's square centimeters.